Oumuamua is the first and currently only interstellar object detected passing through the solar system. It was discovered at the Haleakala Observatory in Hawaii on October 19, 2017. It is essentially space debris that is currently leaving the solar system, having passed near the sun 3 years ago. Interstellar visitors of this sort are not rare. Space is riddled with junk ejected from other star systems by orbital mechanics or leftovers from the death of earlier generations of stars. What's unique about Oumuamua is that we caught it in the act. We could tell it came from the great beyond by its trajectory, a hyperbolic path past our sun that originated outside our system and will return essentially from where it came. Oumuamua is famous because it is tumbling and not smoothly rotating, and is moving so fast relative to the sun that there is no chance it originated in the solar system. Oumuamua appears to have come from roughly the direction of constellation Lyra. No one has seen Oumuamua. It's far too small and distant. It's only been detected as a point of light in a telescope. The images you're seeing are all artistic renderings based on what data scientists have been able to extract. After Oumuamua passed the sun, several observations detected a small acceleration. In a sci-fi movie, that's how you would know it's an alien. But is that really the case? Could this innocuous piece of space debris be harboring a dark secret? Let's find out. After the sighting, papers with titles like "Non-Gravitational Acceleration of Oumuamua" began to pop up all over the place. At least one such paper did suggest that alien propulsion was one possible explanation of the observed acceleration. But there are so many other factors that need to be taken into account. What is the probability that Oumuamua isn't an alien spacecraft and we are just getting our hopes up? Why it could be an alien. I think it's worth reviewing first why Oumuamua might be an alien spacecraft which used our sun as a slingshot maneuver. Well, the most convincing piece of evidence we have to go on is that it passed very close to the sun, just what would be expected if a slingshot maneuver was intended. Oumuamua's trajectory is in the plane of the galaxy, and this is exactly the direction it would arrive from if it was designed to lose orbital speed and head inwards towards the center of the galaxy. Now, the problem for a space probe passing too close to the sun is that it would of course be exposing itself to tremendous amounts of radiation and thermal energy. Oumuamua works around this problem by having a very high variation in brightness. This is just what would be expected for a craft designed to pass very close to the sun, like NASA's own Parker Solar Probe, for example, which has a bright solar shield on one side and is dark on the other. Using the formula in NASA's asteroid size estimator, its relativity would have to be smaller than what we thought possible. The surface would have to be reflecting only 0.0001% of the light incident upon it. Vantablack, on the other hand, the darkest material we've invented so far, reflects 0.035% of light. Spectra taken from the dark and bright sides are significantly different. What you would expect if the difference in brightness is due to different materials being used on either side of the space probe. Could this be a sign of advanced alien technology? Given the scrupulous attention to detail, it just may well be. It showed no tail and no coma, unlike solar system comets. The Spitzer Space Telescope failed to spot it. Spitzer operates in the infrared spectrum. A dark body like an asteroid would have gained enough heat from its encounter with the sun to glow brightly in the infrared region. Thus, Oumuamua should have been observed to be small and shiny. Observations indicating the opposite are still baffling scientists. In fact, no one has come up with a natural explanation of the nature of Oumuamua that satisfies all the observations. It has shown signs of acceleration, but the rotate rate has not changed. Comets typically show acceleration from outgassing, which is essentially gases slowly being vented from their interiors. This process is very chaotic and exhibits drastic changes to the rotational rate of the comet, none of which were observed on Oumuamua. Why it might not be aliens. Now, as to why it can't be an alien spacecraft, as many people have pointed out, there are several interesting claims. The foremost of which is the fact that it showed no interest in us. Well, perhaps they weren't interested in us, and most probably were not aware of our existence. NASA spacecrafts like Voyager 2, which use slingshot maneuvers on giant planets, could not have been turned around if intelligent signals were detected from the moon of Uranus. So, even if they discovered life on Earth, it would be too late for them to make a U-turn. Another convincing argument is that Oumuamua emitted no signal. We detected no signal yet, but if a high-gain antenna was directed towards us, we probably would not have detected it anyway. It would make sense for the signal to be detected once Oumuamua was well clear of the glare of our sun, but none came through. The final argument, and the one most interesting, comes down to what Richard Dawkins calls the argument from incredulity. The proponent of this view is saying, I cannot personally conceive of any alien intelligence, even though I know intelligent life developed on Earth, and there are probably millions of Earth-like planets scattered across the galaxy. Now, granted, This is a more philosophical approach to the idea, but it has been accepted by many members of the scientific community. Conflicting evidence. All we could ever see of Oumuamua was a dot in a light curve. It's the light curve that led to the conclusion about Oumuamua's shape, but that's our best guess. It's an informed guess, but not a certainty. We could plot its path and project its trajectory, which tells us what it does but not why. That's all we have to work with. Given that, we can't state categorically that Oumuamua isn't an alien vessel. On the other hand, we can't categorically state that it's not a big ball of dark ice with a bright streak on it. Or it could be a long, rocky body. Unfortunately, we can't know for sure. And I don't think it's possible we ever will. Is it not practically possible to catch up with the interstellar object? It's currently traveling at 70,000 miles per hour, faster than anything we've ever launched, according to NASA back in 2018. Oumuamua, less than half a mile in length, now is further away from our sun than Jupiter, and traveling away from the sun at about 70 miles per hour as it heads towards the outskirts of the solar system. In only another 4 years, it will pass Neptune's orbit on its way back into interstellar space. As the saying goes, if you rule out the impossible, what's left, however improbable, must be true. And we are very far away from ruling out the impossible, since every unusual characteristic has plausible natural explanations. Also, Occam's razor. Here's what Macro Michelli of Observatorio Astronomo Micro in Rome, along with the 16 other actual astrophysicists and astronomers who looked at the actual data and co-authored the above referenced paper, have to say about that. After ruling out solar radiation pressure, drag and friction-like forces, and geometric effects originating from Oumuamua, we find comet-like outgassing to be a physically viable explanation. Since this is the easiest explanation given to us by an expert team of scientists, it is almost certainly correct. But that is when I noticed that they have now updated Wikipedia and are now calling it a mildly active comet. They have changed their minds and now believe it is a comet, a mildly active one at that. This thing, if a comet, should have been outgassing like crazy as it passed near our sun and forming some kind of tail. Yet now they believe it is a comet. In October 2018, when Harvard astronomer Avi Loeb and his then postdoc Shmuel Bialy submitted a preprint of the Astrophysical Journal, as at the time much of their analysis discussed the possibility of solar radiation pressure or the momentum transfer of photons striking an object. That just happens to be the driving idea behind solar sails that may one day power spacecraft around our solar system or beyond. Loeb and Bialy closed their paper with a more exotic, highly speculative scenario, suggesting that the object might actually be a very thin solar sail, specifically a fully operational probe sent intentionally to Earth's vicinity by an alien civilization. With so much conflicting evidence, even from amongst the scientific community, it is hard to tell what exactly Oumuamua is and what it was doing in our solar system. Some speculate that it could be an extraterrestrial performing a flyby of our planet. Though it seems far-fetched, it's almost impossible to disprove. And by this point, it is very unlikely we will ever know why that small probe traveled from the edges of the galaxy to meet us. So there you are, guys. What do you think about this strange foreign visitor? Let us know in the comments below. If you enjoyed it, be sure to hit the like button and subscribe for more content like this. And as always, thanks for watching.